What I've been able to do is include much more problem solving in class. A great deal. I mean, before we never worked problems in class. There was never enough time. I would do 1 or maybe 2 problems in class after I spent 40 minutes lecturing, and then send them off all by themselves having seen me work these 2 problems. And the information I kept receiving was, well, it looks so easy when you do it. Well, it is easy when I do it. I've been doing it a long time. It's practice that makes it easy for them. And so this in-class problem solving business has been remarkable for them. Now we've looked at how to go about putting a Lewis structure together. I'm going to put a couple of formulas up here on the overhead projector and turn the lights up. I want you to get in your groups, and I want you to calculate or look at and figure out how to draw the Lewis structures for, we're going to have methane, and we're going to have ammonia, and we're going to have nitrogen gas. The process here is not to introduce it in such a way that they can easily do the process, but to introduce it on a superficial way so that they have to use more than just deduction to solve the problem. They have to do some type of inductive problem solving. Configuration to get the valence electrons. Okay, so what do you do?
So 4 times 4. The 4 there, does that like...
means 4 hydrogens.
Do you multiply that by the electrons?
Uh-huh.
So that'd be like 4 valence electrons.
Right. Right. For example, today we looked at Lewis structures, and I looked at HF, and we did Lewis structures, and it's very straightforward as to how the electrons are configured. But then I gave them exercises where they were doing diatomic nitrogen. Well, diatomic nitrogen is not single bonded to itself, it's triple bonded to itself. And if they went through exactly the procedure that I gave them, they would come up with the concept that they had 3 bonds and they only had 2 elements, and it would be a triple bond. But that's not something that I've introduced to them before. It's something that it's a critical problem solving skill. I have done step 1, step 2, step 3. It told me that I had triple bonds, so that's the way I need to put this together, and then raise my hand. Is that correct? Happy. Okay. Now, okay, so you're trying to figure out how many bonds that you need now, right? How do you get the bonds? I think the idea of me being there while they're trying to do that is critical, because it's another one of those next level up thinking skills. Yes, ma'am.
On the bonds again, you just take like 16 minus 8, which would be 8, and you divide it by that?
2.
Oh, you always divide it by 2?
Right.
Oh, on this one I thought we were dividing by 2 because that's what...
No, 2 electrons because there's 2 in a bond. 2 electrons because there's 2 in a bond.
Oh, so you're saying the C4, there's 4 total? Okay.
1 from each hydrogen times 4 gives you 4 total.
Right.
Yes. Okay.
So did I do that?
Yes, you did. That looks wonderful. So the idea, and it dawned on me after I'd done it and passed it all out, you may have thought, having sitting there thinking, she didn't give them enough information to do that. And I really didn't. There are a number of them in class, and some of these kids I had in high school. So I knew that there were a number of them in class that knew how to do this, whether I had talked about it or not. And they were working in groups, so there's usually 1 in each group that will come up with this.
6 divided by 2 is 3 bonds.
Ah. Right, 3 bonds. Are you telling them all about it?
I'm trying.
Okay, good. Are you getting, okay. All righty. Okay, take time out for just a second for those of you who are having trouble, and we'll look at ammonia here. It's made them more efficient problem solvers. This increased amount of time in class has allowed me to really teach them how to analyze the problem and then how to go about solving it.